Hello there, my name is Charles Osvan Msipa. Welcome to a presentation of computation of limits. In this case, we're looking at the limit of a function as x is tending to a point C, which is actually a real number. So, first of all, we're going to look at a rational expression like this, which is we're calculating limit of this rational expression as x is tending to -1. Now, I would like to talk a bit about how do we strategize to get this limit. We recall that if we have got a polynomial, let's say polynomial p of x, and because polynomials are nice functions that are defined everywhere, we always have that limit as x is tending to the number a of the polynomial of x. This is always going to be the value of the polynomial at point a. So, knowing that, also that if we've got a rational expression, let's say the ratio of two polynomials, let's say p of x over d of x, and we're calculating a limit of x, of limit of this ratio as x is going to a. If both p and d are defined at this point a, the limit will actually be equals to p at a divided by d at a, as long as d at a is not equals to 0. Then we're going to use this kind of ideas to evaluate limits of this nature. First of all, remember at the beginning also we talked about the undefined entities like infinite 0 over 0, infinity over infinity, and we also know that if we've got any number a which is not necessarily equal to 0 over a, that over 0, that would be undefined. So when we get an expression like this, I think we first of all we have to reflect what kind of a situation we have here, especially reflecting in terms of these undefined entities. So what we are tempted to do is to take the limit, the value at which we are calculating limit here, and quickly evaluate it. Like in this case, we say -1 squared is 1 plus 2 here, because -2 times 1 minus 1 is 2, minus 3 would get 0 in the numerator, and the denominator would say -1 squared, and that -1 would get 0. So which means we get this kind of indeterminate form, which we can never give as an answer to a limit. So now, to bypass this kind of situation, or to the way which we're going to follow to manipulate this this kind of expression to solve a limit, is factorization. In other words, we try to find if we can factorize the numerator or factorize the denominator in such a way that at the end we avoid this kind of a situation. So what the next step here would say, the limit of this will be equals to the limit as x is approaching -1, and we note that in the denominator we've got a difference of 2 squares, so we can factorize that as x plus 1 multiplied by x minus 1. And then in the numerator also we note that we've got factors x plus 1 multiplied by x minus 3. So as you can see, this rational fraction here is equivalent to that. So, but what we note here is that now we've got a common factor in the numerator and denominator, which will both will simplify to 1. Then the equivalent fraction, rational expression is going to remain there. It's going to be limit as x is approaching minus 1, limit of x minus 3 over x minus 1. Now, what we have here, we've actually a binomial, which is the simplest polynomial, and the denominator of both the polynomial is the simplest polynomial. And we can see that both of these, both the numerator and denominator, their values are different from 0. Now we've managed to evade this situation. So now, since we notice that we've got something similar to this, which is defined because the denominator is not equal to 0, then we can evaluate following this kind of pattern. So now we're going to have limit here as equals to minus 1 minus 3, evaluating the numerator, over minus 1 minus 1. So what we're going to get here, we're going to get this being equals to minus 4 over minus 2. Then simplifying, we'll see that the limit of this rational expression is 2. So it's very important to note that whenever we get these kind of indefinite expressions, we need to do some kind of factorization and see if we can simplify like we did here, and then analyze again if we can evaluate the limit. And once we get to a situation that we can evaluate the limit that we reflected here, then we can evaluate and get the limit and give that as our answer for the limit we required to calculate. So I would like to advise you to practice factorization if you are weak in that, and of course you're going to be able to factorize quadratic expressions because you're going to get them involved a number of times in this kind of limits, cubic expression, even expressions involving power 4. So in other words, factorization here is going to be a very important tool for this kind of work. Now let's move on and look at the second example, which is as follows. Here we need limit. We need to calculate the limit as x is tending to 3. Now again, quickly we need to reflect what would happen if we plug 3 into this expression. We can see definitely it's going to be 9 minus 9 over 27 minus 27, which gives again that kind of indefinite expression, which we are not going to, indefinite expression which we are not going to give as a limit. So again here, what we're going to need, we need to do some factorization. So we will write an equivalent expression of this one, having factorized as follows. Calculate the limit as x is going to 3 over x going to 3 of x plus 3 multiplied by x minus 3 as factors of this difference of squares. In the denominator, like I've said before, you see we've got a cubic expression here. You need to factorize that. I hope you remember this, but I'll remind you in this case because I want to explain this for you. So what happens here, I'm not going to discuss the strategies of factorization, but I'm going to give you factors for this one. But if you've got a problem that you have got to revise your techniques of factorizing such expression, but in this case it turns out that the factors for this expression, which is 3 cubed minus 27, are going to be x minus 3 multiplied by x squared plus 3x plus 9. You can double check that if you multiply that, you can get there. But if you don't know, you don't remember how to do this, then you must go and revise this kind of work. Now, having done this, we can see that we have got a common factor appearing in the numerator and denominator, which both are going to simplify to 1. Then we are left with an equivalent rational expression, which is as follows. Then we write limit as x tends to 3 of x plus 3 over x squared plus 3x plus 9. Now, when we look at this, with this kind of rational expression, we can see that both the numerator and the denominator are different from 0. Then at this stage, we are ready to plug in this value where we are calculating a limit. Then we write it as 3 plus 3 over 3 squared, which is 9, plus 3 times 3, which is 9, plus 9. And then this is going to give us 6 over 27, which you can simplify and write as 2, simplified by dividing by 3 numerator, okay, 2 over 9. And that will be our limit for this kind of expression. So I hope you've seen once more again here that factorization is an important tool for avoiding this kind of indeterminate form. So at this stage, I hope you've seen and heard what exactly you are supposed to do in these types of exercises. I would like to encourage you to go and do some more practice, or some more practice in your text and in your study guide, hoping that way you develop skills to deal with this kind of problems. Otherwise, for now, thank you for listening.